the first place. So what's a great first step to do if you're using the quadratic formula? I'll give you a hint. It's not to just start writing your answer. Mar.
Label the A, B, C.
Absolutely. A equals
2.
B equals
-7.
C equals.
-1.
What's the most common mistake by far when working with the quadratic formula? And can someone pull the window shades down? Mixing the negatives. It's really easy to miss the negatives. Really, really easy. So then after you label the A, B, and C, what's a great thing for you to do? Alex, plug it into what? So what is the quadratic formula?
X equals -b plus or minus b squared root of b squared minus 4ac over 2a.
All over 2a. Now here's the thing. If you just plug it in right now to this whole thing, you're going to write a lot of things over and over again that probably would be easier not to have to write over and over again. What part of that equation is the annoying part to write over and over again? The b squared minus 4ac. Do you remember, I don't know if you remember from before break, that had a name? Do you remember what he called it? Yeah, this thing. This thing right here is called the discriminant. I'm just giving you an order for simplifying that's going to make your life easier. So I highly recommend you do it. So do the discriminant first. In this case, the discriminant is going to be negative what? 7 squared minus 4 times 2 times negative 11. See, I already made a copying mistake. Negative 11. So what does that become? 49 plus what? 88, I think, right? So it's going to be 137. So now what can I write? X is equal to negative, what is B? Negative 7 plus or minus the square root of 137 all over what? 2 times 2. So what do you end up with? 7 plus or minus the square root of 137 all over what? 4. And then you stop. Is there anything really easy you can do to that to make it any simpler?
It's already rationalized.
It's already rationalized because the denominator is rational. Absolutely correct. And then you look at 137 and you're like, I don't really want to factor that, so I'm going to be done. You're done. Just stop. You're done. You're stopped. But when you get an answer like that, this is particularly useful in this case because this means that the factored form is not nice. This means that the factored form is not nice. So how about you ask you to do first? Shh, what did I ask you to do first? A is 3, B is 2, C is... And then I asked you to find, you could write it down, but b squared minus 4ac. What's that called? That's called the what? Discriminant. So in that case, it's going to be 2 squared minus 4 times 3 times 7, which is 4 minus, not 8, 12 times 7. So it's 4 minus what? So it's negative 80. So you end up with x is equal to negative b, which would mean negative 2 plus or minus the square root of negative 80 all over what? 2 times 3, yep. So you end up with negative 2 plus or minus many of you had this. I heard you saying this out loud and thinking you were done. You're not because it's not simplified. So in order to me, plus or minus, it's 4i root 5 all over 6. You can pull out a 4 because what's a factor of 80? 16. The square root of 16 is 4, so you can pull out the 4. Are you done yet? No. 2 and 4 and 6, what does it become? Negative 1 plus or minus 2i root 5 all over what? 3. And now you are done. So this right here is a negative imaginary irrational number.
That's good. You like that?
That's good answer. Good answer. Okay, so just to be clear, I didn't want to make you think that you should never divide first when using the quadratic equation. But let's say I gave you something like this, like 5x squared plus 25x minus 30 equals 0. Yes, if they have a common factor, please do. Like if dividing doesn't change the overall complexity of the initial question, definitely do it. Like, oh look, that's the same as x squared plus 5x minus 1 is equal to 6. I can almost do basic math. Minus 6. And is that factorable? It kind of looks like, well, excuse me. It is factorable. Is it factorable nicely? Does it kind of, because you see 5s and 6s, you're like, oh, x minus 6 and x, maybe x plus 6 and x. Oh, look, it is. X plus 6 times. Does that work?
Yeah.
It does work. So sometimes don't forget the easier the easier methods. Like at least check to see if things are factorable. That being said, on your upcoming test, which isn't going to be for a while, of course, but like tests and quizzes, if it says use the quadratic formula, you got to use the quadratic formula. If it says to factor, use it. That being said, let's say you totally crash and burn and you have no idea, like you lost it. Some kind of answer is better than no answer. You understand what I mean? Some kind of answer is better than no answer. Okay, so just to reiterate, I wanted to just show you again the kind of the math that's involved where the proof comes from. I just want you. I think you guys could prove it for me. Ax squared plus bx plus c is equal to 0. That's standard form, exactly. Now, what did we want to do if we were completing the square? What did we do first? What do we want to get out of there? Coefficient where needs to be what? We literally talked about this. Like it needs to be 1. So what do we divide by?
Oh, dA.
The a. Divide everything by a. If you divide everything by a, you end up with this. Do you remember this picture that he put on the board?
Yes.
And you end up with the same type of work, but does it get a little nasty? It does. It does, it does, it does. A bonus project for all of you, if you want to do it, a bonus would be prove this in class. What I mean by that is if you could get up in front of the class and without a piece of paper in front of you, do this out, meaning get to x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Without notes, you have to get up and just do it and explain it and be able to answer questions.
Can we use like an actual?
Would this be more bonusy?
This would be way more, way more. This would be way more. This would be worth like a quiz grade. If you can get up without notes and prove it, yes. And it's not just writing stuff down. You have to be able to explain what you're doing. Absolutely.
On the LCD.
You could find the LCD, and then once you get the LCD, add it all together, and then multiply. How about I multiply everything by x, and I end up with x over x plus x over x minus 1 equals 7x over 12. Oh, what's x over x?
1.
That's just 1. What happens, kids, you really got to stop talking and watch. I'm giving you the simplest method possible. Do this, then catch up to that later. That's 1. What could I multiply everything by now? I just multiplied everything by x. What should I multiply everything by now?
X minus 1.
X minus 1. If I multiply everything by x minus 1, I end up with x minus 1 plus x times x minus 1 all over x minus 1 equals 7x times x minus 1 all over 12. Hey, what's x minus 1 over x minus 1? So what do I end up with? X minus 1 plus equals 7x times x minus 1 all over. What could I multiply everything by now? 12 times x minus 1 plus 12x is equal to. This is just a quicker way to go about getting to where you got to anyway if you add everything together. What did we get rid of? We just multiplied by the common denominator. All we did there was multiply by the common denominator. Instead of multiplying all at once, I multiplied by the first one, then I multiplied by the second one, then I multiplied by the third one. Now, what kind of equation do we have?
Well, you're going to get a quadratic.
You're going to get a quadratic. Have you finished this, anybody?
Yeah.
What'd you end up with?
3/7 and 4.
3/7 and 4? 3/7 and
I think that's
4?
the final answer.
Correct. Yeah. X does equal 3/7 or 4. That is absolutely correct.
Do you think you can do?
So if we clean this up into, you end up with 12x minus 12 plus 12x equals 7x squared minus 7. Is that the proper form?
Minus 7x.
Minus 7x, thank you. Is that the proper form? No, we need to combine like terms. We have 24x minus 12 is equal to 7x squared minus 7x. So we end up with, we want to make it 0, so 7x squared. Then we subtract 24x, would it minus what, 31x?
Isn't it plus 31?
No, you're going to subtract 24, and then what, plus what?
12.
Is that in the proper form?
Yes.
Yeah, so in this case, what is A?
7.
B? C? Is this kind of annoying because it's big?
Yeah.
Sure, it is kind of annoying because it's big, but you just got to deal. Does this look okay for the people that got it right? Is
I
this?
did the opposite, so I put.
Oh, you put it on the other side.
Yeah, so
Is it going to be the same thing?
Yeah.
It's going to be the same thing, yeah. So if we do it this way, I just did it because I wanted to keep things positive. B squared minus 4ac. Does it get a little big? You have negative 31 squared minus 4 times 7 times 12. What do you end up? What's 31 times 31? 960. What is it?
961.
961 minus 28 times 12. What does it come out to be?
625.
What is? Oh, is 625 a nice number?
Yeah.
Yeah. So you end up with x is equal to negative b. What is b to begin with? What is b?
31.
Yeah. So you end up with negative 31 plus or minus the square root of 625 all over 2 times 7. What is the square root of 625?
25.
25. So you end up with x is equal to 31 plus or minus 25 over. So there are two answers there. There's 31 plus 25 over 14, but what else is there?
31 minus 25.
Over 14. And this actually simplifies kind of nicely. You end up with 56 over 14. And what else do you end up with over here? You end up with 6 over 14. Do these simplify? Yeah, what's 56 over 14? 4. And what's 6 over 14? 3/7. So that's where they come from. Now here's the thing. Are those relatively clean answers?
Yeah.
Sure. What do clean answers imply about the original quadratic? You probably could have factored it, but the thing is, does that look like still it's nicely factorable? No, it's not. It's really kind of no, don't. So if you have these answers and you believe in them, stick by them. This right here is about as efficient as it gets. This is the next section we're going to be covering. You're going to get equations that aren't in quadratic form. You're going to put them in quadratic form and then use the quadratic formula if you have to. Your quadratic formula is your fail-safe. You like to factor if possible, but if it's not factorable or nicely factorable, use the quadratic formula. And then every once in a while, when I force you to, what are you going to have to use? Completing the square. Yeah, you're like, I want to say it out loud. I don't want to make it real. It's like Voldemort. It's scary. No, not that bad. You want to try another one like this? No? You don't? You really don't? Oh, I kind of do. What's the quick way to do this one? What'd you multiply everything by?
35x times x plus 2.
35x times x plus 2. So you end up with x plus 2, 35, plus 2x times 35 equals 17 times x plus 2. So it's a quadratic. It's not like the nicest quadratic, but it's not terrible. What do you end up with? 35x plus 70 plus 70x equals 17x squared plus 34x. Do you guys clean this up okay? Did you find, was there a little algebra mistake in there somewhere? Yeah. I did the exact same thing earlier. I just dropped it, right? I was like, oh, no, it's there. So does it clean up decently? Well, what's the one number in there that kind of messes? What's your least favorite number in that whole list? The 17. You don't like 17 because 17 is what type of number? You don't like primes, but yeah, that's just life. So you end up with 0, 17x squared. So what do you have here? Well, I'll clean it up a little bit first, I guess. What do you get? 105x plus kids equals 17x squared plus 34x. So 0 equals 17x squared minus what x? Minus 70. Minus what?
71.
Is it 71? Yep. So in this case, what's A?
17.
B?
Negative 17.
And C? So are these bigger numbers? Kids. I'm just asking some straightforward questions to engage you a little bit. Are these a little larger than what we're used to?
Yeah.
But does the method change? No. Did I write something wrong?
Yes.
Oh, it's negative 71. Does that change the answer a little bit?
Yeah.
That would make it substantially different. Substantially different. So again, it's kind of like completing the square. The method doesn't change. The numbers might be a little less attractive, but the method doesn't change. Same thing for quadratic formula. Same thing. So what we ended up with right now is we ended up with a solution which we got to using the quadratic formula. We got there from a quadratic equation, right? Sometimes I'm going to give you the quadratic equation and you can use the quadratic formula to get to a solution. Sometimes you're going to use factoring. Are you always going to be given a quadratic equation to begin with? No. Sometimes you might have to do some work, if I could spell it right. You're going to need to do some work to get to the quadratic equation, which then leads you to a solution either through the quadratic formula or factoring. What's that one last method you can't forget about? What's that third method? Yeah, completing the square. So I think you should practice solving these before we get to adding the layer on. And I don't think I said we're going to come up with it in class, right, in the assignment sheet? Anybody actually look up the assignment sheet?
I did.
Yeah, it says.
Yeah, we're going to come up with it. Right, determined. So I think it should be just some relatively straightforward practice. What do you think? Should it be some straightforward practice?
Yeah.
Okay, so we'll stay in 9.2 then. So how about this? Page 511. This is 9.2. Numbers, let's say. Okay, kids, there is your homework assignment right there. 9.2, numbers 5 through 27 odd.